So tonight we're just gonna continue over um, our discussion over UCSF Chimera. So now that you've probably worked quite a lot with UCSF Chimera or tried at least one or two different structures, now that you log in, you see that you have this nice scene tool icons. So you've seen blah blah blah, and more interestingly, right here you have all your past structures. So this can be very useful to just open up maybe a slightly an old structure you've worked on maybe a month ago. It's actually going to be saved right here. You don't need to go back to your files. So UCSF Chimera actually saves quite a lot, as you can see right here. You can go actually quite back out there. We're going to go hop back on into our 1ZNI structure of insulin to do a little bit more representation. So right last time we went over presets, right? Trophobicity surface, all atoms, right? And ribbons. But what if you want to do more? Maybe let's say you want to actually show an amino acid and maybe put a label on it. Well, that option is also supported by UCSF Chimera. You can just hop on, select it with your nice control, click, action, item show. Now to show it. And inside here under action into labels. Labels offer you basically two main branches of options, basically selecting by atoms or by residue. So if we have by atom right here, what we see is all of the atoms get a single label. So a single label. What you can do actually is remove it. So label off, and voila. Now you can also do something very similar with your residues, either by names, so the three-letter code. So here we have tyrosine, something very similar with the single-letter code. So Y, of course, and have a little bit more option with one-letter code. Let's say the identifier, so the position and the chain. So chain A, position 14. You can also have a custom one. So let's say we have hello. We can press apply and hello is going to appear here. If you want to change the color is going to be right here under action color. Hop in all atoms. Move this away. Right here. So what you can have here is either atom label, like we had earlier, bond label, like we don't have yet. Technically, this could have a label, for example, or residue label, which we have right here. Once that's selected, you can actually change it whatever color you want. And this can be done for multiple selections. So let's say let's actually do this right now. Let's say you want to have this one here. You want to have action, show. And you can add a label. Okay, we have a single letter code in this case. Get a good view out of it. And just select that one and do a similar thing with color, all options, and residue, and put it, let's say, green or maybe purple. Okay, so that's things you can do. The problem is, as we are moving, you see they're static. Maybe you want it a little bit further, but you cannot move them. There's other ways to actually put similar to the word text boxes or something a little bit distinct, where you can actually move the object around to actually position it in a way that might be more suitable for your purpose. So now that we're done, select both position with Control and Shift action, and then remove the label through here and off. Okay. Now what you can do now is actually explore a little bit more of these selections of tools. So tools are what you're going to be using probably the most in UCSF Chimera, because they allow you to edit, to analyze, to rearrange in different ways, to adjust the settings of your protein. So there's a lot of them. We're probably not going to cover all of them today. We're probably going to concentrate on those that are affecting the representation. So probably going to be used in the final step of your editing just before taking your protein picture. Before that, there's the general tools. So the tools won't affect maybe a selection that you have, but are going to affect your whole analysis or your whole graphic user interface, so what you're seeing right now. So you can adjust with the command line. So the command line is actually going to replace these menus right here. Can be very useful for experienced users. We won't go over them right now, but they're well covered on UCSF's Chimera's website. Okay, so you can do everything we're doing, even probably more. Just the color, do selection, add an atom here and there, add a molecule in this format without any problem. Okay. Next, what you can do is actually change the model panel. So in the model panel, you have access to all the information of the model. That's quite a lot. There's a lot to cover, but rapidly you can activate or activate all. Activating means allowing you to modify. Okay. So they're basically, as you can see right here, make selected models active, responsive to mouse motion. If not, they're static. They're just there. They're still visually there, but they're not being affected by anything. Can be very useful if you don't want to move anything around except some of your structures. You can activate only some of them and activate the rest. And activation is actually a little bit more, the bottom. Activate, deactivate right here. If not, you have attributes here. So all the different settings, van der Waal, aromatic size, so all your models are going to have the same setting, so whenever they're going to be changed, it's going to be the same, differently to doing individually everything through action, change the setting. Okay, you can close, biological unit. If I press this, what you'll see is actually you having, through the same representation, the whole insulin. So insulin is actually being stored as a hexamer, so actually here, you have this part, but now there's another one right here, and there's another one right here as a hexamer. That's actually the way it's stored in the cell before being secreted. The reason why there's two of these hexamers is simply the way that the PDB was written. As you know, originally we had two of these dimers. The reason is it's actually just the way that the PDB is being written. Okay? But actually this would be a single, this would be a single unit. And these would be simply the two of them being in the crystallized form. Okay. Now that we went over model panel, just compute CSS. That's you're going to compute, let's say you have really, really floppy strands and you think, well, there's probably something there. You can apply it. What you'll see is, actually right here, there's nothing too floppy, but actually UCSF camera would detect if that would be most likely a beta strand or anything else. So actually try to select everything and see what it says. Tool, I'm actually pretty interested. Model panel, and apply. Okay, doesn't detect anything, but you can see it right here. Okay. Copy combine, so you're going to combine structures in a single unit to move them around. Right to PDB as we've seen before. Show only, you can hide structures. Ramachandran plot if you're interested in the general sci-fi relationship in your model. You can do it depending on different amino acids, and you can save it or simply have extra information right here. Okay. Okay. So now that's for the model panel. You can hide rapidly. It's very useful if you just want to hide different structures like I'm doing right here. Okay. You can then also activate and activate them. So if you see activating it, but this is not activated. Okay. You can actually move it around or not. Okay. Actually being moved in all directions or not. Okay. So hopping back into our model panel and just clip it or activate it and actually hide all of these because they've been moved around. So reactivate all these three. Perfect. Okay. Now that's for the model panel. Pseudo panel, keyword shortcuts, probably the most relevant of the two. So here you have different possibilities. And then you can just decide where you're gonna assign it on your keyboard. Okay. So activate all models in a single keystroke. You can do so. Color by element in a single keystroke. That's going to be done through this panel right here. Also, idle and task panel, rarely used. Basically, what's being running right now. So let's say you're running, let's say a blast. it's going to show here at the same time of calculating something else. So all the jobs, all the calculation being done by UCSF camera going to be shown here at the same time. Okay? So view and control. This is quite relevant at the last step of taking a picture. So let's say just zoom in into a protein right here. That's actually from the side. Okay. So now you want to see the side view and basically decide where you're going to see. So that can be very useful. Let's say you have a nice binding site in the middle right here. Okay. Right here. And you just want to show that one. You don't care about what's above, what's under. You just want to show the general microenvironment of that location. You can do so by just cutting basically everything that's above and everything that's under. Or simply you have a really, really, really big protein and just interested in something that's maybe above, so you can basically start hiding what's under. Okay. You can change the camera positioning. You can actually move it from this in a stereo positioning. So as you can see now, you see it's actually shifted. You can actually view it now in 3D with the special glasses. Okay, you can actually go back into side view camera. You can actually having stereo. Okay, you can have also truncated dome. Okay, and simply modo, of course. Okay, so there's different ways you can actually view proteins in 3D if you so wish. Okay, there's rotations, but more importantly, there is the effects. So if you want to make it something of high quality, you can do it here. Slightly smoother. It's actually going to be more efficient if I change the color background to white. So let's do this right now. So go back in background, white, perfect. Zoom back in. Okay, perfect. Okay, let's hop back into tools, view controls, and lighting and effects. Depth cueing. So as you see right now, kind of becomes more bleached as farther away from the camera you're going. You can decide if you want to keep her or not. Silhouettes. So the contour, you can make it really big if you want. If you not, you can make it really small to just highlight the contour of your protein. You can add shadows. Shadows can be very nice. Can make it more like a natural 3D object. Can be a little bit too much sometimes when it's too clogged up or you have a really dense protein. It can be very nice. Transparency. Don't know if you guys can see it. There's a slight change in transparency. If not, multi-sampling. I don't know if you can see the difference, but I see a pretty big difference between the difference of multi-sampling or not. Okay. Lighting. There's actually a field light and a key light. So if you put both together, as you can see, it looks like just one big light shining. Having two lights basically allows you to lower the amount of shadows that you can have. Okay, let's put this away a little bit like this. Perfect. Change the contrast, brightness, fully there. Put it back to 1, to stock contrast. You know, want something high contrast. Okay, very low. Okay, or let's say have a key to fill ratio. So as you see, key to fill, so what's the ratio of one light over the other? If you put it at 1, they're both equal, everybody's happy. Okay, restore it. Okay, perfect. So these are the ways you can actually change the viewing, but you're not changing anything to the protein itself. What you can do now is the depiction. Now we can start changing stuff relating to a protein. So let's say you want to have you now represent ribbons. You could do the same thing if you're surface or atoms. Let's say you want to do it on the surface or atoms. Just toggle through these radio buttons right here. But what you can have right here is change the color. So right here, when we're going to select it, we're going to have strands all in purple, helixes in this beige, yellowish color, and then coils in gray. So coils are going to be location are not really folded, just connecting these two secondary structures. So if we apply it right here, what you can see is we're having the nice purple for our beta sheets, beige for helices, and our gray for these linking regions. Can be very nice depending on your interest. That could be something very interesting. Or maybe you're showing the same protein in its different state. You want to highlight different things for different figures. That could be something very, very interesting. Rainbow, very classic, going from one end to the other into, I don't know what this is, gray. It should be some kind of yellow. GB. Put this some type of yellow. Blah, blah. Okay, let's see. This won't be the best, but okay. And then apply. You can see as we can have a nice transition for every chain from blue to a nice bright green. So that can be very interesting depending on your picture. If you have a really big, really long, say 1,000 or more amino acid, can be very interesting to find where your actual protein is starting and ending. Okay, over other depiction, pipes and planks, very rarely used. It's going to replace our better shoe with planks, basically straight lines, and pipes by every time there's an alpha helix. Through the helix, there's going to be a tube through it. Very rarely used. Nucleotide, just going to be settings when you're going to analyze DNA or RNA. Render by attributes. Okay, so you're just analyzing for different opacity, very high level rendering. I've never personally used it, never had to, but there's a lot of information on this on UCSF Chimera's toolbox. Okay, so 2D labels is going to be the alternative we have spoken about earlier regarding labeling. So let's say we're going to hop back in, and let's say we want to identify this location. So let's zoom in, get a little bit closer, and just show and hop back on to our depiction and 2D labels. 2D labels are pretty much going to create a text box. Okay, so anything right here is going to be really. The problem is UCSF Chimera doesn't know what you're going to write, so a big trick is just to hop on here, toggle. Well, this is ASN 21A. Okay, perfect. Just going to hop back in. ASN 21A. Perfect. Can change the color. I can put red, purple. Can add arrows if I so desire through the same options. And some color keys, but mainly arrows. So let's say you want to have you have a ligand and you want to show the binding site. You can do it through here. Let's say you want to have this label. Oh, I'm still in selection for arrows. Let's change that right now. Okay, so let's take it off. Let's say you have this label. It's super far, super clogged up region. You can point it through these methods. Very useful. Allows you a little bit more flexibility, but a little bit more knowledge is needed to do it. You can also change the writing type. Now, there's not an extreme amount of fonts right here. You know, there's barely 3 are changing the bolds, but can be useful for some situations. Nicely, the UCSF Chimera allows you right here to put some symbols, right? So let's say you want to have a chemical equation. Let's say you work in chemistry. You've found a new method to change specific amino acid bonds. You can do it right here, trying to write the equation right here. Okay. Once you're done, you want to remove it. You don't need to remove it. You can just hide it, basically. Perfect. The arrow weight can be done, and the arrowhead style, right? You can have just a pointy, a blocky, so just a single block, just a line, or a pointer, which would look like this. Okay. The problem, as you can see, is when I rotate, so this is kind of glued to my 2D space, to the X, the Y axis, XZ axis, and this XZY axis, sorry, is still available for the protein to move. So this is the kind of time where you want to actually do something, as we talked about, is basically tool, general, model panel, and simply deactivate it. Okay, so after closing it, it's going to be possible. Let's select all of it. Okay, tool, model panel, and deactivate. So now, as you can see, I'm back here to select, and regardless of what I do, this is not moving. Okay. Now, a big problem now that could be quite relevant to discuss with UCSF Chimera is actually the prompt me to go back. So let's say I'm forgetting, I'm talking to my supervisor, I'm playing with my computer, and I'm adding all of this. Well, you could be tempted to go, oh, maybe I'm just going to go back. And then you go Command Z or Control Z, and you see that nothing is working. Well, there's one way that you could do it, is undo right here. As you can see, there's one step going back, but UCSF Chimera does not actually store all your steps. So actually, now we're lucky, we can actually remove the arrows, but let's say you've deleted an atom. While you're stuck, you need to either re-download your session or re-download the whole PDB. So there's a good trick to prevent this, as I said, is when you show an atom, there's the option delete it, but always hide it. Okay? By hiding it, you're making it disappear from your visual field, but still there to the computer. So if you wanted to make it reappear, you just press on show, no wrong done, still there. It's basically a quick way to bypass the fact of having to re-download everything. Okay, so let's remove these 2D labels. Okay. Okay. Let's remove that one also. I'm still in selection for 2D labels. Okay. Other tools have color action, which is basically our preset that we had before. Ribbon style editor. Okay, so now you can go crazy on your width, on your types of chain for residues, on your representation of your smoothness, of your cross section, of your different regions. You can go crazy with UCSF Chimera, but these usually presets are rarely used. You can promote color zones. You can have, let's see, your binding site, a certain zone, your color key, Pseudo on reader, and surface capping. You don't have any surface, but you can actually cap it and color it in a specific zone also. Okay, now we'll hop onto next video into structural analysis. Structural analysis is personally the type of tools I would use the most in different situations. Allows you to draw a lot of information about your structure. So we'll cover these next time. I hope to see you there. Have a great night. Bye bye.